Hey chemistry crew, Mr. Collier here. I want to go over some notes. These are pages 11 and 12 in your solutions packet. So the process of a solution forming happens, and we're going to focus on dissolving of like a solid dissolving into a liquid, but the process is similar regardless of the state of matter. What we're going to start with is the surface of the solute. So the thing that is getting dissolved starts to interact with the thing that's doing the dissolving. And what you have is a process where we are pulling molecules apart. Now, not a chemical process. We're not breaking the bonds, but we are sort of separating them. And so we're kind of rearranging the intermolecular forces and what's pulling on what where. This process is called solvation. And very specifically, if water is the solvent, we call it hydration. And this is specifically when we're talking about ions separating. With covalent compounds, it's a little different process, but general idea of separating the molecules from one another. We can have energy being absorbed or released during these processes, and depending on whether more is absorbed or released, you can actually have dissolving be an endothermic or exothermic process on whole, where just by dissolving one thing in another, stuff gets hot or stuff gets cold. We've talked about solubility a little bit in the notes already. And solubility is something you can actually measure. So like we'll sometimes refer to solubility as if it's just this, is it soluble, yes or no? But I do want to point out that solubility is actually something we're going to be measuring in class. And so it is the amount of solvent in a certain temperature or pressure that will dissolve. I'm sorry, I think I said that wrong. Amount of solute in an amount of solvent. So like grams per 100 mils or something like that. And we've looked at that on some different graphs. So we're going to see another graph here in a minute. Now, how much of something that will dissolve in something else depends on the solute and the solvent. There's a general rule that like dissolves like. So if you have a polar solvent and a polar solute, they're going to dissolve, and a non-polar will dissolve in a non-polar. Now, water kind of bends those rules, being polar in a way that just dissolves a lot of different things. So, for example, salt dissolves in water because both are polar, and there's some sort of ionic attractions there. Temperature is one thing that is going to affect the solubility. The temperature typically for gases is very interesting, because as the temperature increases, the solubility of gases decreases, but the opposite is going to be true for most solids. Also, if a dissolving process is going to be absorbing heat, then raising the temperature is going to allow you to dissolve more. And the opposite is true. If you have a process that is releasing heat and then you heat it up, it's going to not dissolve as well. It's going to decrease the solubility. So you can kind of play around with temperatures to dissolve more or less to be able to. You can change that solubility. So here's what I was just saying about gases. Most gases, as you raise the temperature, the solubility goes down. And when you're thinking about dissolving gases, one of the key things is going to be dissolved oxygen. That shows up very importantly in biological processes. So for example, in a stream, oxygen dissolves into the stream. That dissolved oxygen is how the aquatic life in that stream gets their oxygen and does their respiration. If you have a stream that gets very warm, you can now hold less oxygen in it, and so the stream health goes down. And so very important there. You can also change the solubility of gases with pressure. So by increasing the pressure, you're basically like increasing the number of collisions. And so you're going to get more solubility. You're going to have more dissolving if they're smashing into each other more often. We can also affect how quickly something dissolves, the speed. And a lot of these are intuitive and things you've probably thought of before. So like a sugar crystal is going to dissolve faster than a sugar cube because there's more surface area. So So you can crush things and they'll dissolve better. Likewise, you can stir, right? Things are going to dissolve faster if you stir them than if you let them sit because you're giving more collisions. Temperature also is going to increase the number of collisions, and therefore, and when I say collisions, I mean the interaction between the solute and the solvent. So you're going to get faster dissolving. And all of these, really, what they're doing is making sure they come into contact more often. So we have the solubility curves. I've already done some different notes on those, so this shouldn't be anything new to you, but you can see many substances will have greater solubility as you increase the temperature. But when you do something like gases, they typically do the opposite, although there's a couple solids that do the opposite as well. And that ought to do it. So if you have any questions about solubility, let me know.